Okay, great. So I taught for 7 years in public schools. I taught physics, so my natural background is in the sciences, but PhET interactive simulations, even though it's in the Department of Physics at the University of Colorado Boulder, it also includes mathematics. So I'm just going to give you just a little bit of an overview of what we do and how we support adult education. But if you have more questions after I'm done talking, I really hope you'll join the breakout session at the start of next hour. So, like I mentioned, we're in the physics department. I'm actually based out of Washington, D.C., though, because my role is as the director of global initiatives. So PhET has been around for more than 20 years now. It originally came out of the award prize money that our founder received in 2001. So he himself, he recently retired, but at the very peak of his career in physics research, he decided he wanted to shift his focus a little bit, and he wanted to focus on education and education research. And so PhET started, and I would say in the past 20 years, I would say probably about half of all science teachers in the United States use PhET simulations on a regular basis. And PhET is being used all around the world. Any place people can get access to the internet, any place people can access internet, even if they just need to download it. We know that PhET simulations are being used an awful lot in a lot of very remote places, places that are nearly off the grid as well. So PhET has this very, very large footprint, around 250 million uses per year, and we've had more than 1.4 billion uses in the past 20 years. So it's pretty big. If you're not in math or science or don't tend to focus on those fields, you might not have heard of it, but it is pretty large, I would say. What we really do is we create interactive simulations, and we'll be taking a look at one in a few minutes. But the underlying goal behind this is we recognize that a lot of learners, students all the way through adults, whatnot, the best way to learn math and science is in science, certainly with laboratory equipment, actually exploring the world, engaging with those physical things around you. And this is true for mathematics in many cases as well, having representations, especially physical manipulatives. But the reality is that most learners don't have, most learners, especially in contexts that are maybe non-traditional or contexts where there's just, lack of resources, it's harder to learn math and science in many cases, especially if you have a teacher who may be less comfortable with the content. So the whole goal behind this is to help students engage with math and science, find relevance in it, make sure that it's accessible to all learners, including learners whose first language might not be English, or learners who have physical differences or cognitive differences, things like that. We also want something that we know is evidence-based and has been shown to lead students and learners to really understand the concepts. And we also want to make sure it's personalized, that students have real agency and voice in their learning. Ultimately, we want to make doing STEM and learning STEM more like doing STEM. So these are, off to the left, just some examples of the simulations that we have. You'll see we started out very, very heavy in physics because that's, well, where it made sense in terms of, where our origins are. But of course, these things are all connected. In order to understand physics, it's good to have a strong grounding in mathematics. In order to understand physics as well, it's great to be able to make those connections to the chemical world and, of course, the biomolecular world. So most of our stuff is in the physical sciences and also in mathematics. We don't have as much in the life sciences because there are so many other good resources out there. And I should mention everything that everything that's on the web is free and open education resources. So like I said, stuff can be downloaded, stuff can be linked to it. Everything is under a creative, the simulations are under a Creative Commons BY license, which means we just need attribution. But if you have textbooks or curriculum, anything really that you're producing, frankly, even if you commercialize it, you're able to use PhET simulations, and many, many people do. So that's made it, again, very accessible all around the world. And I'm not going to go into all the details here, but we've got a lot of evidence, thousands and thousands of studies that show that PhET simulations can be very effective for student learning. So things like the multiple visualization models, the way we represent math and science, we can represent it with graphs, or we can represent it with figures, we can represent it with moving objects, for example. We know it helps students through scaffolding, reducing cognitive load. We also know that when students interact with simulations that give them kind of that like automated real life feedback, that they often self-correct ideas that they might have walked in with that weren't perfect. It reinforces good ideas, of course, and then, like I already mentioned, supports student agency. So the goal here is not to give students a set of tasks to do in math and science, but instead to give them more like a playground where they can explore and receive that feedback that helps to strengthen their conceptual understanding. And we've seen teachers use the simulations in lots of different ways. So as you'll see in just a couple of minutes, PhET simulations, like I said, they're not just do this task, get feedback, do this task, get feedback. It's much more exploratory. And so teachers will often use these as a pre-lab or a warm-up before students come to class or before they have some kind of a in-class experience. Teachers can use them for providing explanations, like doing demonstrations. Sometimes teachers will do them in place of or to supplement physical laboratory. I think supplementing is really fabulous, but there are some cases where you may need to replace a laboratory because you don't have enough equipment, or you're working on electronics and students still can't see the electrons. Even if you're doing something hands-on, there are some things that are just hard to visualize. And then finally, distance learning. And because everything's free and open source from the web, it basically especially allows adult learners to just take their time and to work through things at their own pace. So yeah, pretty much this reemphasizes everything else that I was mentioning. There's just a lot of implicit scaffolding. So none of these tools are meant to be used without some kind of teacher support. That could be in terms of like in-class guidance, questions like, how do you think we could do this? Or how would you make this thing balance? Why do you think that? It could also be a written worksheet that the teacher provides and students or the learners work with on their own time. So somebody who's, I think, a well-focused learner can take a lot of advantage of these, even just on their own. But it is very, very helpful to have a teacher. We're not trying to replace the teacher in any way. We know that scaffolding like that is really important. And it supports multiple learning goals. So let me actually skip ahead a little bit here. And I want to actually show you a simulation. We can come back to some of the other slides. I'm going to drop a link in the chat for a simulation called Build an Atom. And I would like to give you a couple of minutes to play with it yourself. I'll also project my screen. So there's a link in the chat now. That is Build an Atom. And I'd like you to just play with that simulation and record in your mind or on a piece of paper any discoveries that you make. Sometimes a better question to ask is, what do you notice and what do you wonder? And we keep it simple like that. Let me go ahead and pull this over. So I hope folks are playing with the simulation. Has anybody here used the simulation before? And if so, you can just unmute yourself. Let me know.
No, this is my first time using it.
First time.
I've used this.
How have you used this one before? Is that Kathy speaking?
Yes.
Tell me about it. How do you use it?
I gave a chemistry session one time on where I was teaching at Pima Community College, and I wanted them to know about the difference between a neutral atom and an ion.
Yeah.
And so I had them playing around, and they realized that some of them become positively charged, some of them become negatively charged. I thought it was a great teaching tool.
Awesome. Thank you. The other thing that I really like as a physics person is to see whether or not we've got a stable atom or not. But you can see definitely the net charge here. And there's also a few more a few other things we can also explore, things that will give us some additional information about atoms. Would anybody care to share? What have they noticed? What have they wondered at this point? Maybe you don't know anything about chemistry, and that's okay.
I like how it not only addresses the number of protons, neutrons, and electrons, but also their position within the model.
Mm-hmm. Absolutely.
I noticed that the simulation would not tell me whether or not my atom was stable or unstable until it actually had a proton in it.
Oh, okay. I think I hadn't even noticed that myself. Let me reset. So you're saying if I just put in a neutron, it doesn't tell me if it's stable. Oh, it is telling me if it's telling me it is unstable now. Was yours showing you something different?
Yeah, so I started by loading mine up with electrons. I put every single electron that was in my bucket into the orbitals, and I loaded up all the neutrons. And when I click on the stable, unstable, like it'll shake, but it doesn't say the word unstable. But when I drag a proton onto it to make it hydrogen, it says that it's an unstable hydrogen atom. And I think that it's a neat analog to like the difference between having a zero and a null in mathematics.
I see. Okay. And it's interesting you bring up mathematics because this is one that many people actually use to teach positive, the addition of positive and negative values. Um, it's a kind of a real life application of some foundational math. Awesome. The other thing that this simulation does is it also has a bit of a game that you can play with. So this is a little bit more like, direct feedback. Okay, I got that one wrong. So I need to find out. There we go. This is the appropriate elemental symbol for a single, oh, there we go. Hydrogen. Here we've got a helium. And so the question is, what's my number here going to be? Let's see. Nope, I didn't get that one right. And I can keep trying and there we go. So this is just one example of a simulation. There are many, many different types of simulations of different kind of ability levels, or not different ability levels, but different conceptual levels. I'm going to pop in the chat the link to our PhET website. So it's just there in the chat. I'm going to visit it as well. And there's a couple different ways to get to our simulations. You can click on the content area you're interested in, or you can just go to all of your simulations. And you'll see we have 108 different HTML5 simulations. We have a few additional, sometimes you'll hear us say we have 160 simulations. We do have some that are legacy simulations that are older technology. But we tend to focus on the HTML5 ones because these can be used on a computer, tablet, or even on a smartphone, and also Chromebooks, both online and offline. And I see Jeff is concerned about his chemistry knowledge, but that's okay. We're all here to learn. I guess I don't know if I know math tends to be so foundational, and a lot of people don't know that PhET does math. So here's one that I particularly love called center and variability. And this is to help students understand what is a mean, median, what is average. And I think it comes down to a lot of, when you think about math for good citizenship or math for interpreting what is going on in the world, understanding things like averages, means, medians, modes, and statistics in general is just really, really critical. So this is a simulation that allows you to predict where do you think that mean would be. Does anybody have a guess? Where do you think the mean of the distance of each kick, or the distance of all the kicks, what would that be? Does anybody want to guess? Little more than six. I'm hearing six from a few people. Okay. So we've got 2 at 3, 2 at 6, 1 at 8, 2 at 9. I'm hearing, so it could be 6 or a little more than 6. We'll just leave it at 6 for now. And let's see if we can go ahead and get, oh, it is 6. There we go. Helping students to, students could make a prediction, of course. You can have them do things like sort the data so they can kind of get a better sense of what's going on. And we can also learn to represent data with things like box and whisker plots, which I am frankly not super great at because it's not something I use very often. And that's one thing that I think simulations does for many teachers. It helps us to recognize that when we start to approach this again in a very exploratory manner, that we still have a lot to learn. And so then the teachers, in many cases, when we introduce simulations in a very gentle way, the teachers realize that it's okay to explore with students and to not always be the know-it-all or the sage on the stage, and to instead, really accompany students in their learning rather than, be administrators or people who are just providing information, right? So these are just two. I'm going to show one final one, and then I'm going to move on with just a couple closing notes. We have simulations that go to much higher levels as well. So here's one about calculus, which frankly, calculus is very scary to a lot of people. But for me, math did not make sense. The world did not make sense until I understood calculus, and calculus shifted my understanding about the world. So this is a simulation that basically shows what happens when you're taking a look at derivatives. You can also look at things like tangent lines to understand how these two representations correspond to one another. And then in the science, actually, I'll just show you another one really quickly, because I think people don't always realize that you can do a lot of like experimentation with simulations, things that you can't do in the real world or can't do very easily in the real world. So here, for example, we have got a rocket that I can launch. I can do things like increase that initial speed. I could change that angle. And basically what we're dealing with is fundamentals of physics right here. And that rocket went really, 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 really too far. But I can collect data by changing, a variable a little bit of amount at a time, make a graph, and derive some fundamental equations. So that's what simulations are. Sorry about that. Let me get back into my slides. The thing that I wanted to point out in my last just couple of minutes here is that our simulations are available in 121 different languages. I believe everything that we have and produced is in Spanish, and that's the simulations, our website, teacher tips, activities, everything is available in Spanish. But we've got Hmong, we've got Vietnamese, we've got all these different languages, and the top ones for recent immigrants to the United States. We also have accessibility features. So if you're working with students who, even students who are blind or have significant visual impairments, about half of our simulations have various supports. We have things like interactive highlights. We have interactive description where the simulation will read out or speak out what is visually happening on the screen. But we know these things are also helpful for students who might, let's say, struggle with attention, or students who just have preferences for auditory input, things like that. And then we do also have an app. We have a desktop app, which is easily downloaded from our website. We also have a mobile app, which is 99 cents and helps with maintenance. But you can download individual simulations onto a smartphone or Chromebook, again, at no cost. So the 99 cents is more of a convenience fee in case a user wants to have all of the simulations at once on their mobile device. So yeah, I think that's probably, that's actually where I'm going to go ahead and pause. I did want to show just a couple my final slide here. There's a whole bunch of other things I could tell you about, but I know my time is coming down. There's additional resources online. We also have a virtual workshop, which is available on our website and on Coursera. And that workshop can either be within a couple of hours of work, or we have a 60-hour version. Those workshops are for teachers, they're for educators, not for students. And they basically focus on how do I use simulations most effectively in order to get my students just to get as much as they possibly can. How do I let students have agency while still helping to scaffold their understanding towards a particular objective?